Thank you, everybody, for joining us today for our latest Simulation Mechanical webinar. Today we're going to be talking about what's new in Simulation Mechanical 2016. My name is James Kubley. I'm a technical support specialist here at Autodesk, and we're going to have Sualp Ozel giving the presentation. He is the product manager for Simulation Mechanical.
All right, thank you very much, James. Hi, everybody. My name is Sualp Ozel, and I am the product manager for Autodesk Simulation Mechanical. And in this presentation, I'll go over some of the new features included in the Autodesk Simulation Mechanical 2016 release. I am this evening, I am joining this call from Shanghai, from our offices in the Shanghai area. So I apologize in advance if there's some issues with the audio quality due to some of the issues I'm having with my internet connection. So James, please jump in if there's a audio silence. So let's go to the next slide. Thank you. So the 2016 release provides significant improvements in the following 4 categories. CAD preparation for simulation, advanced Nastran support, performance improvements, and usability enhancements. So with the next slide, let's dive into some of these major enhancements in this release. The first category being the CAD preparation. SimStudio Tools is a new geometry prep application that comes with the 2016 release of Simulation Mechanical, Simulation CFD, Simulation Multflow, as well as all the Flex versions of the simulation products. It is a direct replacement for our previous CAD preparation tool called Inventor Fusion 2013. And just like Inventor Fusion 2013, SimStudio Tools runs locally on your system, and it imports models from a variety of sources. It includes unique defeaturing and healing tools that are designed specifically to help our users create clean CAD models that are the foundation of efficient and high-quality meshes. So the SimStudio Tools and Simulation Mechanical are connected so that you can move a model between the 2 packages very easily. When you go from SimStudio Tools to Simulation Mechanical, geometry, part names, and materials will come over. And if you set up an analysis in Simulation Mechanical, and if you add your loads and boundary conditions and contact definition and materials and things like that, upon running your analysis, if you realize that you need to make a design change, you can edit the model in SimStudio Tools, and when you push the model back into Simulation Mechanical, you can simply reuse all your previous settings on the updated model. You can also push models from SimStudio Tools. You can also push models from Simulation Mechanical out to SimStudio Tools as well. So let's say you have an archive file that doesn't necessarily have the CAD file associated with it. You can push the CAD geometry out of Simulation Mechanical into SimStudio Tools to make some edits. Simulation Mechanical still offers associated workflows with most of the mainstream CAD packages, such as Inventor and SolidWorks and Pro-E and SpaceClaim and Rhino and things like that. SimStudio Tools simply provides an alternative solution for you who are looking for a faster way of preparing models for simulation. So let's go to the next slide and move into some of our solver-related improvements. Autodesk Nastran solver is provided with Simulation Mechanical, and it has also been significantly improved with the 2016 release. In this slide deck, I'm just going, in this specific slide, I'm going to highlight some of these improvements, but if you want to learn more about these improvements, there will probably be another episode that specifically talks about all the Autodesk Nastran improvements. The Nastran solver now supports pyramid elements, which are a common type of element from a hex-dominant measure, such as the one that we use in Simulation Mechanical. Autodesk Nastran Editor has been upgraded to a 64-bit version, and it provides enhanced performance and better memory usage. The Nastran critical buckling solvers now supports linear contact between parts and surfaces. We have also improved the output from the solver to show the composite results for each ply. And finally, we've added a new eigensolver that provides a 3 to 4 times speed increase for solving modal analyses where high frequency ranges are required. Let's move on to the next slide and take a moment to go over some of the improvements we've done to Simulation Mechanical to support additional Nastran specific features. So Simulation Mechanical can now export beam element preloads as well as beam element orientations, and we call those K-nodes, to Nastran. Simulation Mechanical can also export and therefore solve additional plasticity material models using the Nastran solver. So here in this picture, I actually show all the different types of plasticity material models we export and solve. So this is Anamnesis with isotropic hardening, Anamnesis with kinematic hardening, and the same two material models with the curve material models as well. So Anamnesis with curve isotropic and Anamnesis with curve kinematic hardening. We have also improved our export to Nastran with respect to contact between parts. So modeling parts with small gaps is a common practice in order to communicate the design intent for contact tolerances. And using the Nastran solvers, excuse me, Simulation Mechanical 2016 can now analyze parts that are separated with a physical gap. And we can do all this while considering the specific contact pairs to be bonded or welded contact for both linear and nonlinear analyses, and for all mesh types, including brick and tetrahedral elements. And with that, let's move on to the next slide and talk a little bit about the additional Nastran support. So the 2016 release also allows you to export pressure loads to Nastran and therefore simulate such loads within the static stress as well as the static stress with nonlinear material model and analysis types. And the same is also true for any kind of load that you apply to a local coordinate system. And upon analyzing your structural models with the Nastran solvers, you can now see both the stress and the strain results within the same load case. In the 2015 release, you had to choose which result you wanted to see. If you wanted to see the stress result, you would check that, and if you wanted to see the strain result, you would check that in different load cases. In the 2016, you can see both results in the same load case. For nonlinear analyses, the 2016 release provides real-time monitoring of incremental Nastran results during the solution phase as well. Of course, all these improvements to the results were made possible by the fact that Simulation Mechanical can now read an FNO file format natively as a solution for the Nastran results. So once you have the FNO file, you can also merge those FNO files into Simulation Mechanical. This means you can basically set up an analysis in Simulation Mechanical, export to a Nastran file, and then if you need to, you can customize that Nastran file in Nastran Editor. You can solve it within the editor, which creates the FNO file. And then you can take that FNO file back into Simulation Mechanical by merging it and do some additional post-processing of your results in the Simulation Mechanical's results interface. All right, let's move into the next slide, which talks a little bit about our next big improvement category, which is focused around performance. In the 2016 release, we've done some improvements to performance, and the process of meshing and setting of the initial element definitions has been made more efficient. This enhancement significantly decreases the time it takes for a given model to reappear in the display area after meshing has completed. In some cases, this is 1,000 times faster. This is especially true for assemblies with a large number of parts. Similarly, the speed of selection for meshed objects and highlighting of selectable entities upon meshing an assembly has been drastically improved as well. We have also completely redesigned the analysis parameters dialog for a frequency response analysis to improve its usability. Which brings me to the final and probably the most important focus area for this release, which is usability improvements. So let's go to the next slide to talk a little bit about the usability improvements. So in this release, we have unified all of the CAD import options into a single dialog box. So in addition, you can now specify the desired options separately for a first-time CAD model import and a CAD model re-import operation. These options will save you a lot of time in your model setup by giving you control over important CAD data such as material properties, part color, and part names during CAD import and CAD re-import process. We have also improved our inventor interoperability. This is one of those categories that we strive to be great at. Year over year, we make improvements into our inventor interoperability. And the 2016 release now can import welded features from Autodesk Inventor models into Simulation Mechanical. If you go back 6 months or so, there was another one of these go-to webinars where our support team told you how to use welds in Simulation Mechanical. And one of the workarounds that we offered back then was to use step files and SAT files. But now in the 2016 release, the welds will appear as just another part coming in from Inventor into Simulation Mechanical. And you no longer need to go through neutral file formats to import your weld design into Simulation Mechanical. Similarly, you can now import all of your 3D sketches from Inventor into Simulation Mechanical as construction objects, and you can reuse them for the basis of beam and truss geometry in a simulation. This improvement eliminates the need to 3D sketch objects in Simulation Mechanical, and therefore is a big time saver for Inventor users who prefer to design their beam skeletons in the 3D sketch mode inside of Inventor. So let's go to the next slide. The 2016 release contains several improvements to the FEA editor as well. Loads such as surface pressure, hydrostatic pressure, and normal forces are now represented in the canvas as vectors, indicating the direction of the load. Previously, if you added a surface pressure, you would just get a glyph with the character P. And if you added a hydrostatic pressure, you would get a glyph with the character H. And now, instead of just text characters, you actually see the arrows that represent the load as a vector, which is a lot easier to understand if the pressure you added is an internal pressure or an external pressure. So let's talk a little bit about the refinement point sphere. In this release we added a translucent sphere, which gives a visual indication of the zone of influence around each mesh refinement point. We also added several selection and visibility improvements to speed up the selection speed for internal surfaces, for enclosures such as pressure vessels, pumps, or valves after a mesh operation has been completed. The mesh refinement studies are an important part of any simulation, right? We don't just analyze our models with the default mesh and look at the results and take those results as our final results. We always recommend that we perform mesh refinement studies. The Mesh Study Wizard, which automates this process by creating multiple design scenarios with various global mesh size refinements, and displays a convergence plot. So in this release, the Mesh Study Wizard has been enhanced to support different load cases for static stress analyses. It has also been extended to cover thermal and electrostatic analysis types. So let's go to the next slide and talk a little bit about our connectors. All connectors generated using the joint, bolt, and centroid creator commands have been updated significantly in this release. They are now all fully associative, which means the connections are updated upon a mesh change, and their parameters, such as their names or which surfaces participate in these connectors, can now be edited fully. In addition, the centroid creator now supports CAD edges. Previously, it only supported surfaces. You can now create centroids and centroid connections for specified surfaces or specified edges. The browser has been improved to allow for mesh refinement grouping and suppression of either selected or unselected parts. The 2016 release includes an easy-to-use remote solving option as well. This will allow users to run analyses on remote computers within their network.
Hey, Sualp, are you still there? You suddenly got very quiet. Does anybody hear me?
I can hear you. I don't hear Sualp.
Same
we
here.
have Sualp trying to go down. Just a second, everybody. Okay, so Sualp's having some connection issues. He'll be right back. Either James or Andrew, do you think you guys could chime in and pick up where he left off with this slide?
it looks like we actually had a couple questions here that we can probably cover while we wait for Sualp to get back. So Andrew Roth is asking if we have any recommendations for remote solving machine specifications. So we don't have specific recommendations, I guess, for simulation mechanical, although there are some recommendations for Autodesk Nastran that have kind of a good, better, best performance. And let me see if I can pull up that knowledge article here real quick. Okay. And James, if you want to open up the link that I just posted there, we can just take a quick look. So these are some of the system kind of specifications that are recommended when working with Autodesk Nastran, which is now kind of a component of simulation mechanical. So I definitely recommend, going with the high-end workstation if you're going to be doing remote solving. You've got the Xenon processor. We definitely recommend more higher clock speed over more cores. So maybe if you can get a 8-core processor that's 3.5 gigahertz versus a 16-core processor that's only 2 gigahertz, that 8-core processor is probably going to have more performance benefit than having the 16 cores. So you can take a look here at some of the other specifications, especially if you're looking to upgrade your laptop or your workstation. These would be some recommendations there. And then one thing also on that remote solving, one feature that was requested a lot this past year was the ability to solve files located on a network drive, and that is now an option in 2016 with that enhancement to remote solving. So if you have files located across your network, and that's kind of part of your standard workflow, you're not now able to solve those directly on that network drive instead of copying them over. Or for some of you in 2015, we had a workaround with a batch file that's no longer necessary in 2016. So that should work with both the Flex product as well as the standard desktop product. Okay, and it looks like another question here from Milton. Do the joints work with parts created in Autodesk Simulation Mechanical, and does it work with planar parts? So plates, for example. So I think that was part of what Sualp was showing there, or what we had there in the PowerPoint, where it's now an option if you have edges. You can now create the centroids with those planar parts, because with a planar part that isn't actually going to be a surface. It's just going to be an edge there. As far as working with, if you're creating hand-built geometry in simulation mechanical, and you want to use the centroid creator there, I think as long as you define it so you have edges there, it should work, but I'm not positive on that, and we can definitely look into that for you and get you an answer.
Hey, Sualp, are you back?
All right, I'm back. Can you guys hear me?
There we go. Yes.
Okay, and another question here from John is where are we with European beam standards and materials? And I think Sualp will touch on that a little bit later in the presentation.
Okay. Hey, Andrew, what was the question with Centroid?
So the question was, with Centroid Creator, is that going to work for parts that are created in simulation mechanical, I assume by hand? And also, is it going to work with planar parts? And I think that was part of the slide there, is that, yes, it will work now because it supports edges.
So if the model is created using any CAD package, it will work for a selected surface or a selected edge. And you can also mix and match those as well. But if you hand build a mesh, we will not be able to find the centroid point for a given surface on a hand build mesh. And of course, if you hand build a mesh, there is no such thing as an edge, right? So we can't use the centroid creator to create the center of a hand build object. I hope that answers that question. All right, so I see that we're in the CFD pressure slide, so I'll continue from there if that's okay. All right, so what we did in this release is we also added a fluid reactions column to the load case multipliers table in the analysis parameters for a linear static stress analysis. You can now apply a reaction force from Autodesk CFD analyses as a load in the multipliers table, and you can vary that by the multiplier per load case. Also, it is no longer necessary to have the unit systems match between Autodesk CFD and the corresponding simulation mechanical models. The units are automatically converted between these two packages. We also added two new loads to simulation mechanical's heat transfer analyses. So let's say that you're adding a heat generation to a given part. Previously, you had to specify that heat generation on a per unit volume basis. And now you can just define that as a per unit volume basis or as a total load. Right? So in the past you had to do, for example, watts per meter cube, and now you have the option of doing just watts as an input. The second one on that list is that for CAD-based parts, you can now define the heat source as a total input for a given surface. Previously, you had to specify the surface heat source on a per unit area. Right? So the example here is watts. It used to be watts per meter square, for example, and now you can just do watts if you want to. All right, so let's go to the next slide. And hopefully this will answer that beam question that I missed a minute ago as well. The 2016 release also improves several aspects of the beam modeling and reporting. So we added the Australian and Canadian beam cross-section libraries to the software. We also added dimensional shape data to all the non-AISC beam cross-sections to enable 3D visualization within the results environment. Right? So this means, let me think, DIN, European, definitely the Canadian and Australian, and Japanese. Those are the 5 non-AISC beam cross-sections we now have. So they now all have 3D visualization in the results environment for the applicable cross-sections. Right? The results environment, previously only the AISC libraries supported 3D visualization of beams. You can also now define L-type beam elements as a user-defined section. The L-type section is available for both linear and nonlinear analysis types. So that's the picture on the top right that we're looking at now. The scope and the presentation of beam element properties have been also enhanced within the report. So now we show the section database, section type, section name in the reports for beam elements, and we also show you a diagram of the predefined beam cross sections and the associated user-specified dimensions in the report. So in this picture, we're looking at a rectangular, beam cross section. So we show you the rectangular image, and also the reference base and height dimensions, and we also show those numbers directly in the report as well. All right, let's move on to the next slide. The 2016 release. In the 2016 release, we have also added several new controls to the Tools Options dialog box to increase some of the efficiency of usability. You can now define a default analysis type for a new model directly within the Tools Options. So for example, if you're predominantly performing heat transfer analyses, you can make that analysis type the default, which means the next time you push a model from Inventor to simulation, we won't stop you and ask you which analysis type you want, and we'll just automatically assign that heat transfer analysis. And this will save you a lot of time during that CAD import portion of your workflow. Using new settings in the application options, you can now define the default viewing behavior for viewpoint manipulation, such as a zoom, pan, rotate, separately for the FEA editor and the results environment. So that's that bottom picture we're looking at. The options, using these options, you can control the display of shading and FEA objects while moving the model. We also added a new control to size the FEA objects directly within this Tools Options dialog. And by default, we show you all those loads and boundary conditions as glyphs, right? A couple slides ago, we showed you the pressure glyphs as arrows, for example. And if you change the size, those arrows can be smaller or larger. And if you change them all the way down to the 0 size, we now shrink them to a point, which really gives you a better visualization for things like local coordinate systems in the FEA editor. So let's move on to the next slide and talk a little bit about the output bar. Log files shown in the output bar have also been enhanced. We added color coding, which means if there's an error message in the log file, the line that has the error message will appear in red, and if there's a warning message, the line that has the warning message will appear in yellow, which makes them much easier to locate. We also added a search functionality to the output bar, which means you can find a word or a phrase by simply clicking anywhere in the output bar, using the right-click functionality and choosing Find, or simply using the shortcut key of Control F to get to that Find dialog. Displayed log file content is now automatically scrolled to the bottom while the analysis is running, so the most recently generated information is always visible. And you can now specify refresh rate for log files displayed while an analysis is running. You can also pause and resume the refreshing of the log file by clicking on the newly added pause buttons. And we also added another option to display the internal nodes for mesh convergence graphs as well. So a lot of improvements in the output bar area. And let's move on to the next slide and talk a little bit about the improvements to the results interface. The results environment has also seen its share of improvements in this release. Probably the biggest improvement to the results interface is the addition of selection groups. You can now create selection groups containing elements, faces, nodes, parts, or surfaces directly within the results interface. So in the picture, the area marked as 1 is what I'm talking about. In addition, part and surface selection groups are shared and synchronized between the FEA editor and the results environment, which is another big time saver when you're working with large models with numerous selection groups. We also improved the Inquire Results by Part tool. So that's the area marked as 3 in that picture. This tool now supports the smoothing function for displayed results. The dialog box also indicates whether interior results are included based on the state of the option for the visibility of the internal mesh within the ribbon. In addition, we show the node number and the XYZ coordinates for the minimum and the maximum results for each part. And we added the save values and save to report buttons to this dialog, which can now save the output of this dialog box to a text file or directly to the HTML report for the current design scenario. The ability to select related objects are also added into the results interface. So that's the area marked as 2 in the picture. So let me give you a quick example there. Let's say you select a surface, and using that section of the ribbon, you can now select the related points, related vertices, or the related part with that surface. We also have added some additional third-party interoperability. Specifically, we added the rigid element support for models that you export to a dynamic simulation tool called Recordyne to be able to connect your flexible bodies to your rigid bodies. All right, let's move on to the next and final slide, which talks a little more about the improvements to the results. So context menus in the results environments have been updated to include visibility, isolate, and show all commands for parts, surfaces, and elements, which means you can basically much easily turn on the visibility of parts. And if you have isolated a part, or if you've isolated a couple of parts, you can simply right-click on the canvas and say Show All to show all the invisible parts with one click. The default editing mode for slice planes have been changed from rotate to translate in the normal direction, which adds a lot of usability to the slice plane function. And another big improvement, one that's really near and dear to my heart, is the improvements in the stress linearization utility. So we've enhanced the stress linearization utility to report the primary membrane stress, primary bending stress, and the sum of the two, the primary membrane plus the primary bending. And we now output these based on von Mises stress combination method as well as the maximum shear stress method. This is a really important improvement for us because it helps to make sure that the results that you get, you can reuse them to make sure you are code compliant with the ASME pressure vessel code. Previously, we used to output only the primary bending stress. I'm sorry. Previously, the primary bending stress was not reported, and we only reported the primary stresses based on the maximum shear stress and not the von Mises stress method. And finally, the mold flow results panel is now hidden if you do not have any mold flow results to look at. And this small change maximizes the display.
I believe we lost Sualp again.
Did we lose Sualp again? Sorry, everybody, for the connection. That's what you get for doing something around the world, right? Andrew, I think this is the last slide.
So it looks like we have a couple other.
Yeah.
Yeah. So it looks like we had a few questions here. So someone was wondering if we can do elastoplastic deformation analysis using this software. So yeah, definitely. We can use what's called a mechanical event simulation, or MES analysis, and we can set up some nonlinear materials. So this is actually covered a little bit in one of our previous webinars about pressure vessel analysis. We go over doing some things according to ASME code, So I think that would be covered there a little bit, and you would just set up a plastic material definition there to do that elastic plastic analysis. So Steve also has a question here. Has the number of allowable nodes been increased in stress linearization? So currently, no, it's still at the about 250,000 node limit. That has not been increased. So I think that was the end of really the slide deck there. If anyone has any other questions, we're here for another 15 minutes or so. So if you want to ask some questions, I'll be glad to answer those.
Hi, Milton. Yeah, that is Andrew talking. Maybe, Andrew, you can create a case for Milton to reach out to him.
Yeah, Milton, if you have some additional questions here about some of the stuff we talked about, I'll be glad to generate a support case for you, and we can touch base there with some additional questions. I know you're interested in some solid edge support there, and we can certainly continue that discussion. See if we have any other questions.
Andrew, you already answered the question on elasto plastic deformation, right?
I did. Yeah, so let's see. I don't know if I have a model handy that I could show this with offhand, but you can actually view the plastic deformation in the results environment. That does require that you're doing obviously a nonlinear analysis, so either a nonlinear static or an MES to view that plastic output there. Let's see. We have another question here. Is Nastran In-CAD and Nastran the same thing? So no, they're two they're separate products. So Nastran In-CAD is a add-in for Inventor that uses the Nastran solvers to perform FEA analysis, whereas Autodesk Nastran by itself is just the solvers, and that's provided with Simulation Mechanical 2015 R1 and now 2016. You get access to that full Nastran solver capabilities with the Nastran editor. So the Nastran In-CAD is kind of a full pre, post, and solving environment. You can't directly edit or you can't make multiple changes to a Nastran file with Nastran In-CAD. It's a little bit more of a limited interface there, and it's targeted if you're a designer or engineer. If you're more towards the analyst level, then Simulation Mechanical and then Autodesk Nastran kind of will fit your needs a little bit better. I hope that answers your question there. Let's see. Are there any examples of thermal stress analysis using creep materials for solder joint fatigue assessment in particular? So I don't think we have any examples of that offhand. But it's definitely something we can look back and see if anyone has any of those examples internally that we could possibly share with you. I would definitely recommend making a post on the Simulation Mechanical forum and see if there's other users out there that have done this type of analysis. People are doing a ton of different things, and they don't necessarily share those with us on support or with Autodesk, but they may be willing to kind of explain how to set up an analysis like that on the forums.
And Peter, in terms of your wish list, I provided you a link there that would take you to the idea station for Simulation Mechanical. I would suggest you go in and post there. That's where Sualp will look through all those different posts, and based on kudos or likes being given to each of those posts for the top ideas, that's where he really draws in what he wants to see in terms of customer ideas for future releases. So I encourage everyone to go there actually and browse the ideas and give kudos to the ones that you like.
Yeah, it's definitely a forum to make a post to if you've got an idea or something you think is going to be a good improvement. I know we've pulled things like being able to run multiple design scenarios simultaneously. That was an Idea Station post. There's been a couple other ones that have been directly implemented into simulation mechanical. So that if there's an idea that you see on there that you're interested in, make sure to give it a thumbs up or add a comment to it. Or if there's something you don't see, go ahead and add that, because that's definitely a place that Sualp is looking at to add new features in the upcoming releases.
Mm-hmm. And as you're looking through there, you'll see some that are accepted and are looking to get put into the system to get implemented, and there's some that are actually already implemented, and it tells you what release to actually take advantage of that feature. So it's good to look at.
So we have another question here about Autodesk Nastran versus MSC Nastran. So there's a couple different Nastrans out there. There's Autodesk Nastran, which used to be NEI Nastran. There's MSC Nastran. There's NX Nastran. They're all kind of different flavors of Nastran. They all use the same bulk data files as their input to do the solving. They all kind of have the same formatting and things like that. So it's just a different option there that's available to you. We definitely want to make sure that if you have the option there to use Autodesk Nastran.
Yeah, so just because you're a Nastran deck, it's a different solver and different capabilities, different strengths, different weaknesses. One thing that the Autodesk Nastran is known for, coming in from the NEI acquisition that we had, is it's really known for being very strong in nonlinear analysis, especially compared to some of the other codes that are out there. So, just because you're a Nastran input deck doesn't mean you're using the same exact solver methodology or approaches in the background. It's just a standard input deck.
And I'd also say too, in addition to specifically nonlinear analyses, composite materials. I think we do a really good job there at handling those. I know we have solid composites as well as your standard kind of 2D composite elements.
Right. Okay, so I think at this point we'll end the webinar. I think the questions have sort of dried up. If you want to know more about the Nastran, and especially the Nastran In-CAD, we're actually kicking off another webinar series on the 28th, so next Tuesday. You can find a post there in the Nastran In-CAD forum to join that series. And if you have a lot more Nastran questions, that's a great place to continue that conversation in the webinar or within the forum itself, and we can really address that. Otherwise, at this time, we will end the webinar, and we look forward to having everyone join for our next one. Have a great rest of the week. Bye, everybody.